Quên mất nội dung rồi, thôi cứ nói tới thôi.
Ra quên mất rồi.
Thì ý là không nhớ chính xác cái flow, thôi kệ em sao.
Không nhớ chính
xác. Good morning everyone.
Nó hay lên.
Now, good morning everyone. Được không á? Nói nghe được thôi, không cần hay đâu. Nói cho thầy nghe là được.
Ok.
Good morning everyone. Today our group will present to you about the topic about the transshipment problem, which is a special, which is which is a modified version of the stream of the transportation problem presented in the class by Mr. Định.
Okay.
Xong rồi qua slide tiếp theo. Here is the members of our group. Our group has 5 members. Xong rồi coi không cần nhắc tên đâu. Một coi để quan trọng. So our talk will be divided into 3 parts. First, we will give some introduction to the transshipment problem by a simple example, as well as some definition related to the transshipment problem. In the second stage, we will present an approach to solve this transshipment problem by converting it from into the standard form of the transportation problem through the concept of buffer amount. And finally, we will illustrate more carefully the solution step by step of the example presented in the first section. Okay. So nhưng mà phải có cái bài phải có cái bài cái đề tiếng Việt. Ý là cái đề bài của cái bài này thì anh không nhớ chính xác đề bài như nào. So on the right hand side here we have an example of transshipment problem. We have some 1,000 amount of goods and 1,200 amount of goods at the source P1 and P2, and we want to move these, and on the node D1, D2, and D3, we have the demand for 800, 900, and 500 amount of goods respectively. So we have to find some way to allocate the goods from P1 and P2 to D1, D2, and D3. But in this kind of problem, we see that we cannot move the goods directly from P1, from the source to the demand, but we have to allocate the source through the intermediate node, which we call in this problem the transshipment node. And on the figure, they are the nodes T1 and T2, so they have no demand or supply. But if you want to transport goods from P1 to D1, for example, then you have to allocate the goods through either T1 or T2, and similarly. So in this, this problem is different from the transportation problem that Mr. Định presented in the class, in the sense that in the transportation problem, the source, the source are connected directly to the destination. Why in this in the transshipment problem, the connections are indirect? So we have to go to the transshipment node or the intermediate node. Okay, so the nodes in the transshipment problem network can be classified into 3 main types. The first type is the transshipment node, which can both receive goods and give away goods. So they have both output and input arcs, and they act at both the source and the destination. The second type is the pure supply node. So it can only supply and only send goods away, but they cannot receive any goods from other nodes. and they only have arcs coming out of it. The third type is the pure demand node, and they can only receive goods, but they cannot give goods away. For example, the node D3 in this this network is the pure demand node. And here is some example on the three type of nodes. In the example figure, we have a network consisting of 4 nodes, and we can see that the node 1 is the only pure supply node. It only has arc coming out. The node 4 is the only pure demand node. It only has arc coming in, and nodes 2 and 3 are transshipment nodes. They have arc coming in both in and both out. What's slide? Cái này, ủa sao nó xuống này rồi? Tức là anh đã giới thiệu cái khúc này từ khúc trước rồi đúng không? Mà bây giờ nó lại xuất hiện lại kìa. Vậy là bạn của Jun đã thay đổi hình ảnh, thay đổi vị trí tự slide.
Thế để em bỏ lên đầu nha.
Thôi anh recording rồi thì lát nữa người ta xem lại thì phải tự hiểu là phải bỏ cái đó ở đâu. Biết em thấy anh nói anh không cần cái slide này luôn. Qua đi.
Đây, đoạn này này. Nó là thêm vào giữa tuyệt đối rồi.
Okay. So we can see that for the now we will present an approach to solve the transshipment problem. So we can see that for the transportation problem already given in the class, the way to solve the transportation problem is to set up a table and then use the streamlined simplex method to solve the transportation problem. But here the transshipment problem is more complicated in the sense that it introduced the transshipment nodes. So, for example, if we on the transportation problem, we have a two-dimensional table, and on one axis we will put the source, and on the other axis we will put the destination nodes on them. But here, for example, if we have a transshipment node, since it can act both as a source and as a destination, will be confused because we do not know which axis we have to put it on. And if we attempt to put it on both axes, then so for this problem, the way to solve this problem is to introduce the concept of what's so-called the buffer amount. And the buffer amount here is defined as the total supply of the initial problem. That is the sum of the supply on all the nodes, or the sum of the total demand, because we assume that the given problem is balanced, which means the supply equals to demand. Chưa mà, từ từ, chưa, đã xong đâu, chưa mà. Okay. So for the so the role of the buffer amount in the buffer amount plays a key role in transforming the graph of the transshipment problem into the well-known two-dimensional table of the transportation problem. So for example, if we consider the example graph here, the in order to move 1,000 units of wood on the node 4, we can either go to node 2 or node 3. So the capacity of node 2 and 3 must be sufficiently large to take the goods. Không đúng, cái này không biết là lấy ví dụ ở đâu, nhưng mà bởi vì là thực ra là cái capacity là cái bởi vì thực ra là hai thằng này nó không gấp vào bao, nên là thực ra capacity của node 2 and 3 là infinity, cho nên thực ra ghi là capacity mới bị sufficiently large, thì đâu chả liên quan gì đến buffer amount. Chỉ đơn giản là because the although the node 2 have no supply goods at it, but in reality the node 2 can still transfer away some amount of goods to node 4 if we first transfer the goods from node 1 to node 2 and then from node 2 to 4. So although the amount of supply at node 2 is 0, but the actual the actual potential amount of goods that the node 2 can supply is 1,000, which comes from node 1, and the node 2 will be able to supply the maximum of 1,000 if all goods from node 1 is transferred to node 2, for example. And so with that idea, the buffer amount can help us to transform the graph of the transshipment model into the 2x2 table of familiar table of the transportation problem with the following rule. So on the new table, the supply of a pure supply node will be equal to its original supply, and the demand of the pure demand node will be the same as the original demand. But however, for the transshipment node, its supply will have to increase by an amount equal to the buffer amount, which I already explained on the above. In case all the amount of the supply nodes transfer to the transshipment node, and then from that transshipment node transfer to the demand node. So we have to add in the buffer amount to all the original supply of the transshipment node. And therefore, to keep balancing the supply and the demand of the problem, we also have to add the demand of the transshipment node by B also. Because we add B on the supply for each transshipment node, so we also need to add B for the demand as well to balance the supply and demand of the problem. Xong rồi qua slide tiếp theo. Thì cái slide tiếp theo thì anh nghĩ là nên để một bên cái hình và một bên là các bạn, tức là hiểu là từ cái hình mình convert sang cái bảng, thì mình sẽ giải thích. Ví dụ như là P1 and P2 will have the pure supply, so the supply will the same as their initial supply, 1,000 and 1,200. Similarly for the D3, the destination tree it is the pure demand node, so we add we keep the demand 500 the same.
Vậy hả?
Nhưng mà bây giờ em phải đừng có làm cái hình nó che mất cái kia.
Em đang gọi nhọn lại nè.
Yeah.
Hẳn trong gọi nhỏ ta.
Để cũng được á, xíu nữa cho mấy đứa ghi chuyện sau. nó không bị khuất, vẫn hết khuất rồi đó, phóng to là được đó. Em bật chế độ slide thế được rồi, đại khái được.
Rồi.
Okay. So for example, the node P1, P2, and node D3 I already mentioned. So they are the pure demand and pure supply and pure demand node. So well, now we have so 4 transshipment nodes, the T1, T2, and D1, D2. Okay. So the node T1, it has no supply and no demand. So we have to add in B supply and B to its supply and B to its demand, where B is the buffer amount and equals in this problem is 2200. So on the table, the node T1 will have the supply and demand both equal B, and similar for the node T2. For the node D1, it has no supply but 800 demand. So on the table, it will have B supply and B plus 800 demand. And similarly, node D2 will have B supply and B plus 900 demand. So we will have the supply and the demand on the table for all the nodes, and then for the price for the cost, for the transportation cost per unit of goods, right? Then we will have the number 3, for example, from P1 to T1, the cost is 3 already given. So we will input all the given price on the arcs in the network onto the table. Then we will set the cost for transportation from one node to itself equal to 0. For example, from T1 to T1, the cost will be 0. From T2 to T2, the cost will be 0. But we can see there are several cells. There are 4 cells on the table which have the cost equal to 0, and these are the cells corresponding to the transshipment node, because the transshipment node will act both as a source and a destination, so they will appear on both the supply column and the destination row of the table. And finally, for all the cells, we will let the cost be M, and the M here means the big M method, and we can understand the letter M here as a very large integer, any arbitrarily large integer. For example, 1 billion, 10 billion, 100 billion, or something like that. And so the introducing the letter M in any cells mean that the cost for transporting through that cell will be very large, and since the streamlined simplex method aims to minimize the cost of transportation, so it will the streamlined algorithm will automatically allocate the goods, not going into the cell having the cost M. So that is the big M method. And we will put the cost M on the cells on which the goods are not allowed to be allocated or moved. For example, we cannot move goods from T2 to T1 because the direction from T1 to T2 is one direction. We only have the direction from T1 to T2, not the reverse. So we will put the cost from T2 to T1 equal to M, very large. So it means we cannot transfer from T1 to T2 to T1. And similarly, if we cannot transfer from D1, D2 to DT1, from D1, D2 to T2, and so on. And then after that, the setting of the table is done, and then we can start solving the problem with this table that we have just set up by the streamline algorithm. Xong rồi em nói từng bước là đầu tiên dùng Northwest Corner để tạo ra initial basic feasible tree solution. Xong rồi tại mấy bước thì lại tính dual vector, xong rồi tính cái reduce cost, đúng không? Xong rồi chọn reduce cost âm, xong rồi chọn cái living variable, xong rồi dùng cái ma trận để chọn cái entering variable, xong rồi update cái tree lên. Cơ mình sẽ làm như vậy hết rồi, là xong hết rồi.
Ok.
Tắt recording nha.